Welcome everyone. I am Ujjwal Pal. Today we will solve a LeetCode problem step by step. The problem number is 1140, which is Stone Game 2. Let's see the problem description. Alice and Bob continues their games with piles of stones. There are number of piles arranged in a row, and each pile has a positive integer number of stones, which is piles of I. And the objective of the game is to end with the most stones. Alice and Bob takes turns with Alice starting first. Initially, aim is 1. And on each player's turn, that player can take all the stones in first x remaining piles, and where x will be from 1 to 2 into m. And then we set m equal to max of m and x. The game continues until all stones have been taken. Assuming Alice and Bob plays optimally, return the maximum number of stones Alice can get. So there will be like stones or piles, or there will be piles of stones, and the number of stones present in a file, it will be given in the given array. And each time we have to choose like the value of x, which will be between 1 to 2 into m, and we will calculate the maximum number of piles or stones we can get at the current position. Okay, and we have to perform that optimally. That each time if it is Ali's turn or Bob's turn, we will calculate the optimal or maximum number that each player can get. Okay, let's see the problem description. Let's see the constraints. The constraints are the length of files will be maximum 100, and each of the element present in files will be up to 10 to the power 4. So let me discuss the algorithm with you. So let's suppose there are 10 files, okay, from 1 to 10, and currently we are standing at ith position, okay, and it is Ali's turn, and we choose at some point the x is, let's say, 2, then j will be at fifth position. Okay, so what will be the maximum number of files that Alice could get at this situation? So we can assume that Alice will get first 3 to 4, all the like files present, all the rocks present here, and then at jth position, Bob will start, and Bob will also play optimally, and we will use recursion function to perform that, because the algorithm will be same to calculate the ith position maximum number and jth position maximum number. So we will assume that the recursion function will give us the maximum number of files that at jth position that Bob could get, okay, from fifth to last element. So if the recursion function give us the maximum element from the ijth position, so the remaining elements, like if there are 5, 6, 7, 8, 9, 10 files are present, so Bob can't get all the element, like it will give the maximum that could Bob get, and the remaining element will also will be added with allies. So allies will get 3, 4, and the remaining elements of this subarray. So which will be equal to, let's say, ally, first we will assume allies will get all the remaining elements like from 3 to 10, and we will subtract that from like the given, like which the value will be given by the recursion function, which is the maximum piles that could get, like Bob could get at j position. Okay, the remaining element, we will assume that all the remaining files will get, allies will get all the remaining files, and we will subtract that the files at jth position Bob could maximum get. So that will give us the if li start at current position, and if the current x value is 2, then what will be the maximum number of files that allies could get. This will be the value. And to get that, like if we are standing at ith position, to get all the sum from the remaining element of the remaining elements, we will use suffix sum array. Okay, first we need to create the suffix sum, so that at each position, if we are standing at each like any element, so we can get all the sum of all the elements, remaining elements. Okay, that's it. So let's see how we can do that. So let's say n equal to files dot size, and to make a suffix array, suffix sum array, so we need to create a vector of int suffix sum array. Let's say sum, length will be n, and the sum of last element, which is n minus 1, will be equal to files of n minus 1. And for the remaining elements, I equal to n minus 2, I greater equal to 0, I minus minus. For rest of the elements, sum of I equal to sum of I plus 1 plus files of current element, which is I. So after this follow, we will get the suffix sum. And now we will use a DP to store all the combination, because we need because like if you see this, if we currently standing at I, we will can be have like x equal to 1 2 3 4 5. So x equal to 1, so j will be here, and x equal to 2, j will be here, x equal to 3, j will be here. And let's say for this position, x is 1 means this position. So you can see that j is standing like in 4 5 6 again and again. So we will store that in a DP, so that we do not need to calculate again and again the same value, because at like fifth position the maximum value will be stored in a DP, so that if any of the cases, if again we have to find the same maximum sum, like for that index, we will be like doing that in big O of constant time. Okay, we will just return the value from our DP. So we will use a DP. So DP size will be for each of the index. That means DP size will be n cross for all the like combinations of x. X could be from 1 to 2, 2 into m. So 2 into m will not exceed the last, like we are finding for remaining element. Remaining elements means the in last index would be n minus 1. So it the 2m will not exceed the n. So you can assume the like our DP will be of like DP size will be of n cross n. Okay, and it will be n plus 1, because at zeroth position, let's say the size of files is 1, and for one position the like there the last index is 0. But if we choose x as 1, then 0 plus 1 will not be present. So we can add 1 here, n plus 1, and initially all values will be 0. Now we will return the helper function is the recursion function, which will give the actual result. Initial value will be, it will take files, the sum, and obviously our DP, current index, which is 0, the maximum index is n, and the m, current m is initially 1. So that will be our parameters. So int helper, first argument is files, second is the sum, suffix sum, third is our DP, and I, which is the current index, in n, which is the last index, or int m is the current m value. Okay, this will be the parameters, and we'll check if I exceeding like n, then just return 0 because there is no files are present. So maximum files which we could get, so that will be 0. And also check if dp of I of m is already present or already calculated or not. If it is already calculated, then we just return dp of I m. Okay. Now we have to calculate like each of the values, like we have to calculate the maximum of for each of the values of x. For each of the values, first we need to create a overall maximum element. Initially, let's say it is 0, and for each of the values of x, let's say x equal to 1 to x less equal to 2 into m x plus plus. For each of the value of x, we'll create the j will be I plus x. We check if j is exceeding n or not. If it is exceeding, first, if it is exceeding, that means all the remaining element is going to ally. So we will get max equal mx equal to max of mx, comma the remaining element, that means suffix sum of I, because we are currently standing at I position and all the remaining files are getting, allies is getting all the remaining files. So it will give the max of this and we will break that. Okay, that's it. If it is not breaking, then we need to first we will check, like we will take all the elements sum of I. We will assume all the elements is getting allies and we will subtract that by like all the elements, maximum element that could like Bob can get. So it will be files and the remaining cell will be sum, dp will be the same, I will be like j, because from jth position Bob's turn, like Bob will start from jth position to all the remaining elements. So next element like where Bob start will be jth position, n will be same, and m will be as given max of m comma x. That's it. So we will to calculate max equal to max of mx and 10. Okay, and we need to return that also. And along with when we are returning, we need to store that also in our DP. So we'll return that. Okay, this will be the recursion function. Let's see, will it work or not? It is accepted. Let's submit it. So it is accepted. Let me discuss the time and space complexities with you. So the time complexity for this for loop is big O of n because we are calculating the suffix sum for all the elements. And for this recursion function, we need to check the time complexity because this for loop is from 1 to up 2 into m, up to 2 into m, and 2 into m could be maximum of n, because if it is exceeding n, then we are just breaking it. So it could be, we can assume it is maximum of big of n times this for loop will run, and for each of the big of n times we are calculating the recursion function, and it is calculating for each of the combination of I and m, because we are creating each of the combinations, like we are storing in dp for each of the element and each of the combinations of m. So this will take big of n square time, because m could be maximum of, as I said, it could be maximum of n, and I will be from 0 to n. So this recursion function will take maximum like big of n square time, and we are checking it for all the elements, like all the values could possible for x. This is also big of n times. So the overall time complexity for this recursion function will be big of n cube, and that is also the overall time complexity for this whole code will be big of n cube. And space complexities, we are creating a suffix sum which is taking the big of n time complex n space complexity, and we are creating a DP for all the combination of I and m, and I will be from 0 to n, and m is also maximum could be n. So the overall space complexity for this DP will be also big of n square, and so the overall space complexity will be big of n square. So thanks for watching. If you want to check out the code, you will find it in the description box below. So that's it for today. See you in the next video.